explained, we have discussed the pH scale, Sorensen scale, then relation between pH and pOH, which is found to be pH plus pOH is equal to 14. Now here we will learn next point. The point is hydrolysis of salt and types of salt. Now what is salt? Do you have any best example of salt? Yes, sodium chloride, NaCl, common salt, table salt is a best example or better example of salt, sodium chloride. And we know that salt is made of reaction between acid and base. So sodium chloride consists of which acid and which base? Sodium chloride consists of NaCl, consists of a strong acid HCl and strong base NaOH. So let us see the reaction between acid and base to form salt such as sodium chloride. So here we are taking a strong acid HCl and strong base NaOH. To form salt such as sodium chloride, NaCl. I just round off here, NaCl salt plus water molecule H2O. So this is the formation of salt. As we know that any salt is made up of reaction between acid and base. Now this is also called as neutralization reaction because formation of water. Now sodium chloride is a salt, and we know that sodium chloride is made up of strong acid and strong base. Strong acid such as hydrochloric acid and strong base such as NaOH. Now what is the definition of salt? We know that NaCl is salt. Now theoretically, what is the definition of salt? Salt means compound. Salt means any compound which contain cation and anion, means one positive ion and one negative ion. So salt is defined as a compound which contain cation and anion. Cation from base and anion from acid. So salt is a compound which consists of cation and anion. Cation from base and anion from the acid, and this is also called as a neutralization reaction. Now when you dissolve sodium chloride salt in water, water can break the NaCl salt into ions, Na plus and Cl minus. So when you dissolve sodium chloride into ion, water break the compound, water break the NaCl into ions, Na plus and Cl minus. So when NaCl, when you dissolve in water H2O, that give us two ions, Na plus Cl minus, aqueous. So when you dissolve NaCl in water, we have two ions, Na plus and Cl minus. But in such case, the ions formed by the breaking of water, they do not react with water further. The ions when produced by water, means when water break the salt such as NaCl and formation of ions. Now these ions do not react with water further. Only water molecules surround the ions as like this: H2O, 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 H2O. Similarly, as like Cl minus surrounded the water molecule H2O, 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 H2O. These ions, Na plus Cl minus ion, after breaking do not react with water further. Only the water molecules surround the ions such as Na plus and Cl minus, as we have discussed in the 11th standard, that we call ion dipole interaction. So this is called ion dipole interaction, and when water molecules surround the ion, that process is called hydration, not hydrolysis. So these ions of sodium chloride undergoes hydration. They do not undergo hydrolysis. Means NaCl only undergoes hydration process because water molecules surround the ions, but these ions, when after breaking up by water, they do not react with water further. They remain as it is. That is why we can say that NaCl do not undergo hydrolysis hydrolysis reaction. Means NaCl, we can say that in case of NaCl, hydrolysis of salt does not take place. Why does not take place? Because NaCl, we know that NaCl is made up of strong acid and strong base. And any salt, NaCl or any salt which made by strong acid and strong base which do not undergo hydrolysis reaction. For example, NaCl, we have another example of salt which made up of strong acid and strong base which do not undergo hydrolysis, such as KCl. Another example, NaNO3, KNO3, Na2SO4, sodium sulfate. So these examples, NaCl, KCl, NaNO3, KNO3 are made up of a strong acid and strong base. So they only produce ions when they dissolve in water, but then these ions do not react with water further. That is why we can say that these salts do not undergo hydrolysis, or they do not give hydrolysis of salt. But we have another example of another salt which undergoes hydrolysis of reaction. For example, ammonium fluoride. And ammonium fluoride made up of weak acid and weak base, such as NH4F is made of weak base such as NH4OH and weak acid such as HF. Here NaCl is a salt, but it is made up of strong acid and strong base. Here also ammonium fluoride is a salt, but it is made up of weak acid and weak base. Now when NH4F dissolve into the water, as like we dissolve in NaCl in water, it gives us ions, as like similarly similar case happen in case of ammonium fluoride, which made up of weak base and weak acid. When dissolved into the ion, it gives us ions such as NH4 plus F minus, aqueous. Now whether these ions NH4 and F minus further react with water? Yes, these ions NH4 plus and F minus further react with water, which is not shown in case of NaCl. When dissolved in water, these ions do not further react with water. They remain as it is, only water molecules around it. That process is called hydration. But here these ions, which is made up of weak acid and weak base, these ions react with water. So coming to this, when NH4 plus further react with water, reversible one, which is formed again weak base such as NH4OH plus H plus. So this is acid. H plus means acidic. And similarly F minus react with water, further react with water, reversible one. This is aqueous, again to form HF, weak acid, plus OH minus, again aqueous. So this is the difference between one salt and another salt. This is the difference between sodium chloride salt and ammonium fluoride salt. Sodium chloride do not react with further water, these ions, but in case of ammonium fluoride, when they dissolve in water, they give us ions, and these ions again further react with water. Equilibrium established between reactant and product. NH4 plus react with water to form again weak base such as NH4OH, and F minus react with water, again further react with water to form weak acid such as HF and OH minus. So in that case we can say that this is hydrolysis of salt. So here we can say that NH4F undergoes hydrolysis. NH4F undergoes hydrolysis of salt, or we can say that hydrolysis of salt, the best example is ammonium fluoride. Ammonium fluoride undergoes hydrolysis of salt, means we can say that in case of ammonium fluoride, hydrolysis of F hydrolysis of salt taking place, which is not shown, which is not observed in case of NaCl. In case of NaCl, hydrolysis of salt does not take place. Similarly, KCl, NaO3, KNO3, we do not observe the hydrolysis of salt. But in case of, because they all made up of strong acid and strong base, but in case of ammonium chloride, it undergoes hydrolysis because these ions further react with water to form acidic solution, or OH minus means basic solution. So this is called hydrolysis reaction. So this is the difference between hydrolysis and hydration. Hydration means only ions, cations surrounded by the water molecule. In that case, ions do not react with water further. But in case of hydrolysis reaction, the ions by breaking of water further react with water to form acidic solution or acid, or basic solution or base. So this is the difference between hydration and hydrolysis of salt. Now we will define the definition of hydrolysis of salt theoretically. What is hydrolysis of salt? Hydrolysis means a reaction in which the ions such as positive ion, negative ion, means cation or anion of salt, react with ions of water to form acidic solution and basic solution. So this is the definition of hydrolysis reaction, a reaction in which the cation or anion or both ions of salt such as ammonium fluoride react with ions of water to form acidic solution or acid or basic solution. That reaction is called hydrolysis of salt. So this is the difference between hydration and hydrolysis of salt. My next point is types of salt. We have total 4 types of salt. Number 1, the salt which is obtained from strong acid and strong base such as sodium chloride, KCl, KNO3. That salt which is obtained from strong acid and strong base such as sodium chloride, that we have already seen, we have already discussed in the last part. So the salt obtained from strong acid and strong base. Then second type, the salt which is obtained from the reaction between strong acid and weak base. This is strong acid and strong base. This is the salt obtained from strong acid and weak base. For example, copper sulfate, copper chloride, CuCl2. Then third type, salt which is obtained from weak acid and strong base. For example, CH3COONA, sodium acetate, and Na2CO3, sodium carbonate. And the last type of salt, the salt which is obtained from weak acid and weak base such as CH3COONH4, ammonium acetate, NH4CN, ammonium cyanide, and ammonium chloride, NH4F. So there are 4 types of salt: strong acid, strong base, strong acid, weak base, weak acid, strong base, and last one, weak acid and weak base. So one by one we explain the types of salt. So first we will explain the first type of salt, such as the salt which is obtained from strong acid and strong base such as sodium chloride. So let us find out the explanation of salt. First type of salt which is obtained from strong acid and strong base. So we have discussed here, we will explain the types of salt. Number 1, salt obtained from strong acid and strong base such as sodium chloride, potassium chloride, KNO3, or sodium sulfate, Na2SO4. Now the salt such as sodium chloride, the information about NaCl salt that we have already discussed in the previous part. Now these type of salts, means the salt which is obtained from strong acid and strong base such as sodium chloride, KCl, and KNO3, are called as neutral salts. They are called as neutral salts. Neutral salt. Why they are called neutral salt? Because we know that neither the cation nor the anion react with water. So the equality between H3O plus, concentration of H3O plus and OH minus will be not disturbed. It remains intact, it remains same. So that is why they are called neutral salt. For example, sodium chloride, KCl and KNO3. We know that Na plus or Cl minus do not react with water. In other words, we can say that when they react with water, such as Na plus Cl minus plus water H2O, to form again a strong electrolyte such as strong acid, HCl, and strong base NaOH, and they are called as strong electrolytes. So this is strong acid, strong base, so these are called strong electrolytes. We know that they are called strong electrolytes, strong acid and strong base. And because they strong electrolyte, we know that they dissociate in water completely, almost 100%. So so at the end, the product and reactant are the same. So the concentration of H3O plus is equal to and the concentration of OH minus will not be disturbed. So it remains in the concentration of H3O plus is equal to the concentration of OH minus, or we can say that the concentration of H plus is equal to the concentration of OH minus. The concentration of H plus OH minus, or the concentration of H3O plus and OH minus remains same. So that is why they are called neutral salts, because we know that when NaCl, KCl, KNO3 dissolve into the water breaks the salt into ions such as Na plus and Cl minus. If you dissolve NaCl in water, that give us ions such as Na plus Cl minus. But in that case, these ions do not further react with water. Means they, Na plus Cl minus, do not react with water further. In case they react, they form again strong acid and strong base, strong electrolyte, and we know that this strong electrolyte completely dissociate into the water. So that is why the concentration of H3O plus and the concentration of OH minus is not disturbed. That is why they are called as neutral salts. We see the second type of salt, which is obtained from a strong acid and weak base such as copper sulfate, CuSO4. The last was the salt obtained from strong acid and strong base such as sodium chloride. And we know that any salt which is obtained from strong acid and strong base do not undergo hydrolysis, because neither the cation nor the anion of that salt react with water. So the equality between the concentration of H3O plus and OH minus do not disturb. Means the concentration of that case in case of H plus and OH minus, or H3O plus and OH minus, is same. The equality between concentration of H3O plus and OH minus is not disturbed. That is why the solution of strong acid and strong base, or the salt of strong acid and strong base, is a neutral one. Now we will see the second type of salt, which is obtained from strong acid and weak base such as copper sulfate, CuSO4. We have another examples, the salt obtained from strong acid and weak base such as copper chloride, CuCl2, or ammonium nitrate, NH4NO3. So let's take an example, first example. Now we will discuss the first example. We will explain the first example, salt which is obtained from strong acid and weak base such as copper sulfate, CSO4. Now copper sulfate obtained from which strong acid and which strong base? Copper sulfate is obtained from strong acid such as H2SO4, and weak base such as copper hydroxide, CuOH twice. So this is the salt which is obtained from strong acid such as H2SO4 and weak base such as copper hydroxide, CuOH twice. So SO4 is a part of this SO4 is a part of a strong acid, means anion is a part of strong acid, and cation Cu is a part of weak base. So SO4 is a part of strong acid, means anion, negative term, is a part of strong acid, and Cu2 plus cation is a part of weak base. And when strong acid, weak base combine together to form salts such as copper sulfate. Now copper sulfate is a strong electrolyte, so that is why it dissociates completely in the aqueous solution. So I will write the reaction of aqueous ionization of copper sulfate, aqueous CuSO4, aqueous, strong electrolyte, it dissociate almost completely, it goes ion Cu2 plus SO4 2 minus, aqueous. Now out of two, Cu2 plus and SO4 2 minus, SO4 2 minus ions do not react with water further, because we know that SO42 minus is a part of strong acid, and any part of strong acid or strong base have no tendency to react with water, means there is no hydrolysis in case of strong acid and strong base. So SO4 minus is a part of strong acid, so it does not take part in hydrolysis, have no tendency to react with water. But the Cu2 plus ion can react with water, because Cu2 plus ion is a part of weak base. So Cu2 plus ion react with ions of water or water. So here I will write reaction Cu2 plus aqueous. Here I will take a 4 water, H2O liquid. Equilibrium is established between Cu2 plus and 4H2O, giving us again weak base such as COH twice, and acid is formed, acid substance formed. Which one? H3O plus 2 times. So this is aqueous, this is aqueous, which means H3O plus is acidic one, that we already discussed. So in the last lecture, the species which carries positive charge in most of the sites is acidic one, and the species which carries negative sign are base most of the cases. So H3O plus, so plus means acid, minus means base. So this solution, copper sulfate solution, contain H3O plus, and H3O plus means acid substance or acidic one, and it contain, the copper sulfate solution contain excess of H3O plus. So that is why we can say that the copper sulfate solution is acidic one. So copper sulfate solution, this solution is acidic one. Why it is acidic? Why the aqueous solution of copper is acidic? Because it contains excess of H3O plus ions, and we know that the species which carries positive charge are the acidic substance, negative basic substance. So H3O plus is the acid substance, and the copper sulfate solution contain excess of ions of H3O plus. So that is why the resulting copper sulfate solution, the copper sulfate aqueous solution, is an acidic one. And we know the strength of acidic solution, it turns blue litmus red. So the resulting copper sulfate solution is an acidic one, and it turns blue litmus red. Blue litmus red. So that was regarding the second salt which is obtained from strong